Welcome to an introduction to chemistry, brought to you by Parkbench Tutors. For more information on Parkbench Tutors, look us up on Facebook or visit parkbenchtutors.com. This is the second podcast about chemical formulas. Let's start by considering what we mean by a molecular formula and an empirical formula. An empirical formula is simply taking the simplest number of atoms of the elements as a ratio that are needed to make a compound, whereas in contrast the molecular formula is the actual number of atoms of each element that make up the compound. So how does that work? Let's take an example, hydrogen peroxide. The empirical formula is simply HO, but HO doesn't actually exist. What exists is the molecular formula H2O2, hydrogen peroxide. Okay, how do we find the molecular formula? We have a compound which has got an empirical formula of C2H2 and it has a molecular mass of 70. How do we work out the molecular formula? Well, carbon has atomic mass 12 and there are two lots of hydrogen, so we have a mass of 2 for those. Add those up, that's 14. So divide the 70 by 14, we get an answer of 5. So then multiply the empirical formula by 5. So C5H10 is the molecular formula. That compound is in fact pentane. Okay, let's look at percentage by mass. We have a compound which has got 71.5% calcium, 28.5% oxygen. What's the empirical formula? What we know from this is that if we had 100 grams, we would have 71.5 grams of calcium and 28.5 grams of oxygen. So let's divide each of those by the atomic mass of the element. First of all, calcium has an atomic mass of 40.1. So I'm going to divide my 71.5 by 40.1. I get an answer of 1.78. I do the same for oxygen, and again I get an answer of 1.78 there, which means that my ratio is 1 to 1. So I know that my empirical formula is CaO. Now let's take the molecular mass and formula mass. Molecular mass is for compounds that exist as formulas, and it's the mass of a molecule. Whereas we've got ionic compounds, we usually refer to it as formula mass. That's the mass of a formula unit. In reality, that's just the ratio of cations to anions in the compound. So they're two different concepts, but you would do the calculations in the same way. Add up the mass of each atom involved in the compound and you get your answer. So what's the molecular mass of water? This actually tells you that water is existing as molecules here. So the formula is H2O. There are 2 hydrogen atoms to 1 oxygen atom. Hydrogen has atomic mass 1, oxygen atomic mass 16. So 2 lots of hydrogen, 1 lot of oxygen, 1 plus 1 plus 16. The molecular mass is 18. Now the formula mass of calcium hydroxide, we've used formula, right? So calcium hydroxide is ionic. The formula is CaOH twice. So there's going to be 1 atom of calcium, mass 40.1. 2 atoms of oxygen, because it's OH twice, that's a mass of 32 for those 2 atoms. 2 atoms of hydrogen, it's a mass of 2. Add them all up and we have a total of 74.1, and we refer to these as atomic mass units. So let's find the molecular mass of carbon dioxide. Note molecular mass again here. So it's a molecule of carbon dioxide, CO2. The molecule contains an atom of carbon, mass 12, 2 atoms of oxygen, each of mass 16, that's 32. So a total of 44. Okay, just one more of these. Find the formula mass for barium nitrate, so it's ionic. BaNO3 twice is the formula, so work it all out. Barium has a mass of 137. There are 2 nitrogen atoms, 14 apiece, that's 28. There are 6 oxygen atoms, each has a mass of 16, that's 96. Add all those up and we have a total of 261. What do we mean by coefficients? Let's consider an equation here. 2H2 plus O2 gives 2H2O. The H2 with the subscript tells us that there are two atoms of hydrogen that form a molecule of hydrogen. The H2O subscript tells us that a molecule of water has two atoms of hydrogen. Now the number 2 that prefixes the hydrogen and the number 2 that prefixes the water, they're called coefficient, and they refer to the number of molecules that are needed and the number of molecules that are formed. So 2 molecules of hydrogen plus 1 molecule of oxygen gives 2 molecules of water. Let's look at coefficients again. Let's take the equation that you'll often see written as the summary equation of photosynthesis. 6CO2 plus 6H2O gives C6H12O6 plus 6O2. So in this equation we've got coefficient for coefficients are found in front of carbon dioxide, water and oxygen. 6 molecules of carbon dioxide, 6 molecules of water. They will give 1 molecule of sugar, glucose, and 6 molecules of oxygen. Let's go through some of these again. Subscripts after atoms shows the number of atoms. So CaCO3, that 3 there means there's 3 atoms of oxygen. And subscripts after atoms in parenthesis show the number of ions, polyatomic ions. So the 2 there means 2 hydroxide ions in the formula unit. And sometimes you get a positive or negative ion, and that's written as a superscript. So Na plus, note the plus is a superscript there, that shows as a positive charge. Ca2 plus shows there are 2 positive charges on the calcium. And coefficients are placed before atoms or molecules to show the number. So 5N2 means 5 molecules of nitrogen. Wow, let's go through all this again. Subscripts after atoms show the number of atoms. Right, so 3 atoms of oxygen. Subscripts after atoms in parenthesis show the number of polyatomic ions. So 2 hydroxide ions. Superscripts with a positive or negative show the charge on the ion. So Na plus is a single positive charge on sodium. Ca2 plus is 2 positive charges on an ion of calcium. Coefficients are the numbers that we place before atoms or molecules to show the number of atoms or molecules. So 5N2 means 5 molecules of nitrogen. This ends our session on Formulae, brought to you by Parkbench Tutors, narrated by David Hopcroft. Thank you for watching and for listening. For more information about Parkbench Tutors, look us up on Facebook or visit parkbenchtutors.com.